All right, let's look at the basics of a parallel circuit. Now, in order for it to be parallel, we need multiple paths with one resistor per path. So when I'm talking about paths, I'm talking about going from one side of a battery to the other side of a battery, or one junction to another junction. Okay? So for instance, on the way from this junction to this junction, I could go through this resistor to get there, or I could go down through this resistor. Or I could go all the way down and over and up, okay? So there's multiple paths to get from this point to this point with only one resistor per path. That is a parallel circuit. So as soon as you can identify a parallel circuit, you can apply these ideas. One, all the resistors have the same voltage drop. Meaning, if I think about this as a 20-volt drop from this side to this side, I got to drop from 20 volts to 0 volts. I got to go from 20 volts to 0 volts, 20 volts to 0 volts. So they all have the same voltage drop, all of the resistors. What this also means is that the currents add up, meaning that that current that comes out comes down here and that current splits. Okay? All of that current splits and then it comes back together on the other side. So I have my total current to start with, and then that current splits and goes through those resistors. So that total current is equal to the sum of all the individual currents of the paths. Okay? Now, the last one's a little more different. It's just we add the inverse of the resistors, add up to the inverse of the total resistance. Meaning the inverse of the total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And so we can write it as this fraction form, or we can write it as this inverse form. So we use that -1 key on our calculator, and so we do R1 to the -1 plus R2 to the -1, add them all up, and then inverse our answer, and we will get our total. For those curious people out there as to why that happens, we'll look at that and then we'll do an example problem. So if I start out with Ohm's law for my totals and I divide my I total over, which is the sum of all the individual resistances, I flip both sides. Okay? So now I have V total on the bottom. I distribute that V total to each one. And now remember, voltage is the same for each of them. So instead of V total, I could call this V1, this one V2, and this one V3. And then I see I have I over V, which is 1 over R. So I have I1 over V1, which is 1 over R1. And I see I get that inverse relationship there. So let's go ahead and let's set up a problem and we'll try this out. All right, so we've set this up. We are going to have a 2-resistor parallel circuit with 12 volts acting on it. And I want to find two things. I want to find the total resistance of this circuit, and I want to find the current in each one. And those two currents should add up to the total current. All right, so let's go ahead and start applying some things. So I want to find the total resistance. Now the total resistance is one of the first things you want to do when we deal with a complex circuit. And if you're looking forward to that video, there's a link down below in the description. So in order to find the total resistance, what we need to do is we need to add up the inverses and then inverse it. Okay, so I need to add up the inverse of 6, which is 1/6, and the inverse of 3, which is 1/3. So I need to do 1/3 plus 1/6, which gives me 1/2, and then I need to inverse the 1/2. So I have then 1 over R total is equal to 1/3 plus 1/6, and so I get 1 over R total is equal to 1/2, and so R total is equal to 2 ohms. And that follows along with that whenever we have a parallel circuit, the total resistance is less than any one of the individual resistances. All right. Next, I want to find the current in each one. Now the voltage for each one is going to be the same, so the current is going to be equal to voltage divided by resistance. So the current in one is going to be voltage for 1 divided by resistance for 1. So 12 divided by 6, so the current in one is going to be 2 amps. Okay. And the 3, okay, so the current in resistor 2, V1 divided by V2 divided by R2. So I have 12 volts divided by 3 ohms gives me 4 amps. And you see that the total here is 6 amps. Well, is that what I get when I do I total is equal to V total divided by R total, which the total voltage was 12 divided by the total resistance of 2 gives me 6 amps. Yes, it works out. All right.